Hi. So what I'm doing today is Venn diagrams and set notation. I gave a test to my grade 10s. So this test can be used as a revision lesson, or you can also print out the copy of this test from my Google Classroom. Towards the end of the video, you will get the codes for you to join my grade 10 and grade 11 Google Classroom classes. And in that, you will see a lot of material that you also can use. All right. So the very first question here that I have asked the learners to do is that they're supposed to shade. Now, the thing about shading, your syllabus doesn't explicitly say that you must shade, but I don't know how else this notation will make sense if you don't consider certain things. So the shading part is also very important. So you're supposed to shade the set A intersection P complement in the Venn diagram. Right, so this could be a little bit confusing. So what I like to do is I like to number or put numbers in the sets like 1 here, 2 there, 3, and 4. All right, and then what I'll do is I will take everything of set A, and I know that set A is the elements are 1 and 2, and what is not in set P, because that is what does P complement means here. Everything not in P is 1 and 4. Now the intersection means what do they have, what do they share, and as you can see, the one is what they share. So from this one is it's a member or is an element of both. So that means that is the part that you really need to share. All right, there are other methods and styles, but I like to use this one. Right, then the B part says there are 30 students in a class and 10 study Afrikaans, 18 study Portuguese, 5 study neither. So please don't now think this 1, 2, and 3, and 4 has to do anything with that. I just use these to be able to help me with my shading. Right, so it's basically straightforward. The 30, 5 are not doing any of these. So Afrikaans, Portuguese, or both is the union of A and P. All right, so it has to be 25. So that 5 would be, if we were to basically write it down, all right, that 5 will be it will be written anywhere here in the universal set. It will be the learners who do not study anything. All right, so when you want to find how many study Afrikaans but not Portuguese, now this is where it becomes a little bit more interesting. So you can take the 10 plus 18, but you realize 10 plus 18 is going to give you more than 25, which is equal to the universal set, or the 30 basically. So I subtract 25 from the 10 plus 18. That is going to give me the 3. The 3 that I have there are the learners who are not studying anything. There are other ways that you can do this as well, but obviously you'll see that towards the latter part of the video I'm going to introduce some X and so on. All right, so learners who study Afrikaans but not Portuguese, Afrikaans but not Portuguese, they are 7 in total. Okay, right, so you have to find how many learners study both. So the learners who study both are 3, so that 3 will be here, for example, and the learners who study Afrikaans but not Portuguese, that is 7. That learner, those will be here. So suppose the question was asking you how many learners are studying Portuguese now. All right, so if you know that Portuguese are 18, so it has to be then 18 minus the 3, okay, which gives you 15. So 15 learners are studying Portuguese only, and then the 7 you get by saying 10 minus 3. So the 10 minus 3, which is the total learners who are doing Afrikaans, all right, and the total learners who are doing Portuguese, they are 18. So that's what I know. All right, so as I said, this is quite straightforward. There is going to be another question where you will see me bringing a little bit of algebra in order to help you with this type of question. Right, so I'm going directly to the second question. The second question says that you have to complete this table. So first of all, you have 100 people. They will ask which magazines they read. Half of that, that's 50, they say they don't read magazine A or magazine B. They don't read any of them. So that 50 is supposed to come outside. Okay, so that is what the Z will actually equal to. And 27 read magazine A, 43 read magazine B. Now, how many people read both? All right, so we are looking for both. We're looking for the people who read magazine A as well as magazine B. So it is this intersection area here, this overlap. Okay, right. So first of all, what I like to do is I like to put my information, as you can see. So I know that set A consists of 27, set B is 43, and I don't know how many people read both, so I replace that with an X. Okay, not to be confused with this X. So if I want to find the number of people here, it must be 27 minus whatever that is, and for here it must be 43 minus whatever X is. So the whole thing should add up to 43 for set B, and the whole set A should be 27. Right, but set Z we know is 50 because it's half. So we can already complete that 50. Now, in order for us to find, we can take the union of A and B and let it equal to 50. That means I take 27 minus X plus 43 minus X, and I let that equal to 50. Or I can add 27 minus X plus 43 minus X plus 50 to give me 100. And then I can solve an equation from there. And that's what I did right there. So that equation then cleans up nicely to 120 minus X equals to 100. So obviously you're going to get X is negative. Negative X is equal to negative 20. So therefore there are 20. So this X here is actually representing 20 people. 20 people are reading both magazines. Ultimately, you could also have done it this way. You can say 27 plus 43. That is, if you add your two sets together, you get 70, which is more. All right, but now to find both, you say 70 minus 50. Those are the people who are not reading any of the two. All right, so that's going to leave you with 20. So the 50 is going to be what these two sets should equal to. Right, now you're supposed to fill in the missing numbers. Obviously, I know that that is 27 minus, remember X, the value of X is 20, so 27 minus 20 is 7. This is 20 here, and that is 23. All right, so we already know that that is 50 there on that side. Right, in set notation, W equals, this is this particular W here, the number of elements of A intercept the complement of B. Right, so we're supposed to write in a similar fashion for expression Z. So what you are realizing, if you just break down what this tells you, all right, this tells you the number of elements. So let me just see if I can just quickly write it with a pen. We're not asking for the number of elements. We just want you to write it in that notation. But what this is here, if you look at A, the values of A is going to be the 7 and the 20. Okay. If you look at what is not in B, what is not in B is the 7 and the 50. So from this, you can see obviously that particular 7 is what they have in common. All right, so if they were asking you to find that particular question, you would have probably down wrote 7 if the number of elements would be 7, but that's not what we're looking for. We're looking for a way to write Z using this notation. So the one way of doing it is, of course, by looking at the union of A and B, what is not in A and B, because Z is outside. It's the 50 there is not in A or B. So you take the union of set A and B and the complement of that, what is not in A and B, that is what that can represent. Okay, so Z equals to N, the union of A and B complement, or another way to write it is you take the number of elements of A is the complement of A intercept the complement of B. These two statements are actually equivalent. Question 3, so what we have here is we have got a Venn diagram, and the question here says there are 22 students in a class, 15 of them study physics, so I will be taking the 22 is the universal set, 15 for physics, 17 chemistry. So I indicate it like that so I can know that this particular set here for P represents the 15 who study physics, and here for C represents 17 who study chemistry. and 3 study neither physics nor chemistry, so they will be outside. So you put them anywhere, all right, in the rectangle there. And now we are supposed to complete or using algebra. So we must find the number of students who study both physics and chemistry. So we're looking for this intersection, this overlapping region here. So what I do is I like to, because I don't know what it is, I like to represent that by x. And obviously here it must be 15 minus that particular x, and here it must be 17 minus x. So from here you can actually create an equation. You know that this 15 minus x plus 17 minus x, even if you add these three, it should give you 22. All right, that's one way of doing that particular question. Right, so if I clean this up, I'm going to get that x is equal to 13. So I know that the learners who are not doing or who are not studying physics nor chemistry, they are 13, or who are studying both. Okay, learners who study both. The learners who don't study chemistry and physics, so we already know that's 3. Right, so another way of doing it, obviously you take 15 plus 17 plus the 3, and then you subtract from 23, because 15 plus 17 plus 3 will give you something more than 22. Subtract 22, then you get that particular answer. But I am very much in favor of using the algebra like this. Right, on the Venn diagram, you're supposed to shade. So let me just bring that Venn diagram back. All right, so again is the shading part. So I do it step by step. We took a number in every region. So I'm going to put my numbers as you can see there. All right, and then what I do is I'm going to find the set of the P complement intersection C. Now, whatever is not in P, so I can write down whatever is not in P. So I know that 3 and 4 is not in P. And the elements of C is 2 and 3. And as you can see, they have got the 3's common there. All right, so that is the region that we are supposed to shade like that. That's one way of dealing with that particular question. Right, question 4, you have got 4 numbers here, 2.6, 4 over 17, square root 12, square root 112 by 7. And you're supposed to fill them in here. You have to choose which one is rational, so you put them under rational. What is an integer? What is an irrational number comes obviously outside here, the rectangle. So 2.6 is a rational number because it can be written as a fraction, a vulgar fraction. You can write this as a fraction. Okay, 2.6 is 2 wholes and 6 over 10, 3 over 5. If you simplify it, it can be written as a fraction. Anything that can be written with a numerator and a denominator, as long as the denominator is not equal to 0, is a rational number. Right, so 4 over 17 is obviously a fraction, vulgar fraction, so it is also a rational number, so it therefore comes in the same region under rational numbers. The square root of 112 by 7 is an integer, and if you clean this up, you're going to get a whole number, because integers are positive or negative whole number, and square root of 12 is an irrational number. It cannot be written as a vulgar fraction. You can't write it as a numerator over a denominator, so it comes in outside the set of what is rational integers, so it will be part of irrational numbers here. Maybe just something that you should remember what rational numbers are. Remember, they are represented by a q. Irrational is a q with a dash. All right, and we are saying integers with a z, so 112 by 7 is 16, square root of 16 is 4, so the answer is 4, and 4 is an integer, and integers are positive or negative whole numbers, including 0. 0 is also an integer. Okay. Question 5, again, you have a diagram here, and you're supposed to shade the area, which is represented by A union B complement. So what I do is put a number in every region, like so. And then I'm going to get the set of A union B complement. So I know that A is 1 and 2. That is what the elements that are there according to my numbers. And B, the complement of B is what is not in B is 1 and 4. The union means you have to write them, combine them, but you do not repeat a number. So it's going to be 1, 2, and 4. All right, so that means that where my 1, my 2, and 4 is, that is the region that is supposed to be shaded. And that is how I do this particular question for 1 mark. Right. Just a thing about the union, you must think of combine together. That is why you have to take 1, 2, and 4. All right. For this particular one, you are supposed to describe in set notation the shaded area that you have in diagram 2. Now you can see it's the union of A and B and what is not in the union of A and B. So you can say A union B complement of that, all right? Or another way is to write A complement intersection B complement. So these are two possibilities. I believe you probably go with the second one. It's much easier to arrive at. So the complement of set A intersect with the complement of set B, or the complement of the union of set A and B. Well, I do not suppose you write them in words. I want you to use the notation as it's there. So I just included this word part so you can have an idea how to read this or how to interpret this particular notation. Question 6. You were supposed to, I added this question, so I also asked this question in the examination for the grade 11s. So x is an integer. So an integer we know from our previous question that is all positive whole numbers or negative whole numbers. But in this particular case, we're looking for all integers, all whole numbers between 1 and 10. So I can just write them down as they are. That represents the universal set. Then set A is represented all the factors of 12. So we know that the factors of 12 are numbers like 1, 2, 3, 4, and 6 from the universal set. These are numbers that go into 12 while leaving a remainder. Then B, all odd numbers between 1 and 10. Odd numbers are numbers like 1, 3, 5, 7, 9, and 10. So you can write them down as well. And set C, prime number. So prime numbers between 1 and 10, again, two factors only, two numbers going to them is 2, 3, 5, and 7. You can already see from my three sets here that the 3 is common, so it will be something that is going to be common to all three sets. So we have got our particular Venn diagram here, and the question will ask us to complete the Venn diagram. So I can bring in my 3 there because it's going to be overlapping with the A, the B, as well as the C. So everything else, you know, set A, you can put 1 and 2, but you must now look at set A and B, they share a 1, for example, so that 1 is going to be there, and so on. So this is how it is. So I hope that you've paused and also arrived at the same particular answer. Right, so now I ask the students to use set notation to complete the statement. So 6 blah 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 of A. Now well, you can see 6 is an element of A. Element means the member of it belongs in set A. All right, and here obviously A intersection B intersection C, it means what do all of them have there? You can see obviously from there it is that 3 there. Please put it in brackets. If you not put them in curly brackets, it will be marked wrong. Now this particular question, A intersects whatever is not in A, that's going to give you the empty set. So A and whatever is not in A, there is nothing that they intersect with. All right, so that means if you look at all the elements of set A, well, you can write them down if you want to go that route, and maybe I should do that quickly. All the elements of set A, according to that, is 1, 2, 3, 4, and 6. These are all the elements of set A, and all the elements of what is not in set A, the complement of that. The complement of that is going to be, well, you can write them down. Maybe you can start with 5, 7, 8 is not in set A. 9 is also not in set A, as well as 10. Now, if you look from the 2 that I have done, there is nothing that intersect. There's nothing that overlaps there. So the way we write nothing is we either put curly brackets like that, space in between, that means it's the empty set, all right? Or we write that particular notation for the empty set. So that is what I expected the learners to arrive at. 1 mark for each of that question there. Right, and then you have to find the number of elements that you find in set B. Well, set B, the number of elements, you can just see it's going to be 1, 2, 3, 4, 5 elements. That is exactly what I have there. There are 5 elements in set B. Right, then the B question also about set notation. So I've got set X, Y, and Z here with all of these particular elements, and W doesn't belong to neither set X or Z or Y. First question, you're supposed to complete the set notation here. It says UV, you can see they are in curly brackets, so we are looking for what can you say with respect to set Z? Well, they are a proper subset. Now, proper subset means when you find an element like U and V, they are subsets of Z because they belong in that. All right, there is not something more, there's no W there, but U and V are elements that are found in set Z, but they are subset, a proper subset of set Z. Okay. Now, what is important about that last part that I put here, a set can be a subset. So you have got set Z, you can have elements there that are also subsets. So UV is a subset of Z, and also maybe T and U, and so on. Maybe I'm going to bring in this particular part here, where if you want to find out the number of subsets that you can find from a particular set, you know that, let's look at Z. It has got 3 elements, and we know that it's always going to be 2 raised to the power of n, and because there are 3 elements, I'm supposed to get 8 subsets. So I've listed them all here. An empty set is a subset of it's a proper subset of every set. T is a proper subset of this the set Z here, TUV. U the same, V the same, TU, TV, UV, and the subset means each element exactly the same elements. That is why you have that subset notation there. Okay, so suppose this was TUV, not necessarily in alphabetical order or whatever, it would have been a subset. But because it's just U and V, they are proper subsets. Okay, so as you can see, we have got 8 if you count them exactly, subsets that you can get. But I just put this information just so as added notes or to remind you of how to approach a question like this. Right, then there is a part here where it's going to involve us to shade something again for 1 mark. Okay, we're supposed to shade x-intercept with the union of z and y complement. Right, so the way you do it, again, step by step, I'm writing down all the elements of x, and I'm going to write down the union of z and y, what is not in z and y. And what is not in z and y is p, q, and w, p, q, and w. And I can see that I have got P and Q that is common, and that is the part essentially that you're going to shade where there is P and Q, which is this particular area over there. All right, so what I have here, I have my Google Classroom codes for grade 10. You join my classes with this code TZ53MMI. When you want to join the grade 11 classroom, you can join it with MYA3DUO. You can post a question on a topic, whatever you struggle with. I can make a small video for you, or I can help you solve it. Don't forget to subscribe to the channel and also press that notification bell.